Problem 4. Let's talk about the first law. First of all, I want to mention this is a rule. This is not a formula. It's not something you're going to just plug numbers in. You have to create the problem each time. It'll get more complicated. We're going to train you early on, but things will progress and become very much more complicated. First law is this. And you're thinking, what the heck is that? Well, you know this is 0. You know this is an equal. You know this is F. And the F in this case stands for force. But what are those? This is called sigma. It's a Greek letter. Okay, you might want to put this in your left column. Sigma is a Greek letter, and sigma in mathematics means you're gonna add. It means summation. It means you're gonna add multiple things. The reason why you use this, however, instead of plus signs is because when you have pluses, you know exactly how many things you have already. This is a rule, which means we don't know how many things we're going to have in a problem. So that's why we use sigma. Sigma just means as many items as you have, you're going to add them all up. If we're on the x-axis, then it's going to be sigma f of x equals 0. And if we're on the y-axis, this will be sigma f of y equals 0. Fy equals 0. These little things on here, they're supposed to be small. These are called subscripts. It means that 0 means equilibrium. You see the 0 right here? It means 0 is equilibrium. Either it's at rest or is going at a constant velocity. That's what this means. What do I do with this rule? This is a guideline. All the forces, all of the forces go on the left side, and then the right side is always going to be a 0 for first law. We have all the forces. Some may be positive, some may be negative. It all depends on how we set things up. A free body diagram is a representation of forces acting on an object. Okay, so we usually draw the shape, and what we do is then we put a little dot in the middle of the box, and we draw the arrows from that dot. Only forces are drawn on a free body diagram. We will talk about acceleration, we will talk about mass, we'll talk about velocity. Those things don't belong. Only forces. For the summary, in problem 4, is this a formula to plug things in? Take a moment to explain. Free body diagrams. Let's go ahead and show you what this means. One force pushes an object to the right at a constant speed. Constant speed means that this is equal. This is first law. This is equilibrium. So you notice that there's a box right here. There's a dot in the middle. From this point, I'm going to go ahead and draw an arrow going this way. And this is the force that's pushing it to the right. Now you're thinking, okay, Mr. Over, that's pulling to the right. Okay, if you don't want to put it that way, you can also put it the other way as well. Traditionally, we go ahead and don't have forces going into a dot. We usually have going out of the dot. So all that I'm pretty much doing is I'm copying and pasting this and moving it over to this side. Regardless, so this object is moving to the right. Part B, an object experiences tension as it's held in place motionless. So this is the ceiling right here. There's a string holding it in place, and there's a tension that's going up. That tension is being felt on the string. However, I would have you consider that there's also a weight going down. So be aware that tension and weight are two special types of forces. There are many types of forces, and we will be talking about them in greater detail as we go through these videos. Notice how we drew the arrows in the directions they're going in. It's important that when you have more than one arrow that we have signs for these. For example, we can make up be positive and down be negative. Or if you want to flip it around, that's perfectly fine. We can make down be positive and up be negative. Let's draw a free body diagram for an object moving with a constant velocity to the right. So I'm going to go ahead and draw on the floor, draw on the box, put a belly button. It's going at a constant speed. It's being pushed to the right with a force of 10 newtons. Capital N represents newtons. This is the unit for force. Draw a free body diagram from an object hanging from the ceiling. It weighs 50 newtons. Don't forget the belly button. Draw the belly button. And then notice, we always draw these arrows from the center. Okay? From the center. I will be looking at that as you do these problems. Make sure you draw them from the center. So for example, in this case, I have a tension going up and I have a weight going down. and the weight is 50 newtons. Now, if this object is just hanging from the ceiling, do we know what the tension will be based on what we observe? In this case, if it weighs 50 newtons, what might the tension going upward be if this thing is not moving? Consider this for a second. If I go ahead and hang a string from the ceiling or tape it to the ceiling, okay, and it is dangling there, do you notice a tension in the string? When I go ahead and attach a weight to that string, let's say a very light weight, maybe like a piece of candy or something, do we find some tension on that string? Compare that now, instead of a candy, what if I go ahead and put a water bottle to that string? Will the tension be greater? Does the weight of the object attached to the string affect the tension? Is the weight of the object equal to the tension of the string if the object is not moving? Well, let's talk about Disney's Mulan, and not that Mulan, the real Mulan. Okay.
Yes! Perfect. Now we'll pull them to safety.
I'm alive! I found the lucky cricket!
We need help!
Ooh, nice! Very nice. You can sit by me. Ah! We're gonna die! We're gonna die! I'm definitely gonna die! No way we survive this! Death is coming!
I let them slip through my fingers.
I knew we could do it! You the man! Well, sort of.
For this summary, you're going to go ahead and consider the following. What goes on a free body diagram? So what do you actually draw on a free body diagram? Feel free to pause and take a moment to reflect on that and summarize that.